Hello, and welcome to the first talk of the Quarkus track. And thanks for coming to JNation. Thanks to JNation for having us. My name is Stephane Epardaud. I work for Red Hat. And this is Stuart.
I also work for Red Hat.
And we have Twitter accounts, apparently. Which button? Yes. So today, we're going to talk a lot about Quarkus, and this is the first talk about Quarkus. We're going to give an introduction about Quarkus, what it is. The most important thing is that it's an open source stack to write Java applications. It's focused on deploying your applications to the cloud. So from the start, it's meant to be supporting cloud-native applications. And as such, it's very focused on microservices as well as serverless and smaller applications. From the start, we have focused on three main goals for Quarkus, and a lot more, but the four big goals that I'm going to present today. The first one is developer joy. We want to make sure that when you pick up the framework, it's as enjoyable as possible for you to use. So we want to make sure that it's going to hold your hand, it's going to be easy to use, easy to learn, and a pleasure to use every day. So we pay a lot of attention to user experience in the framework. For example, when you start using Quarkus, you don't need to configure anything. We make sure that by default, most of the extensions that you use can be used without any configuration. We want to make sure that editing your code is as easy as possible, so you get live reload. In the blink of an eye, you can just change your code and have it and see the results right away. We base a lot of our work on standards, but whenever we can improve on the standards, then we do. So just to make sure that you get the best experience possible. We made also sure that all the configuration was in the same place, and we want to make sure that all the common usages are really trivial to do. So we focus on what most people are doing and make sure that this is trivial to do in Quarkus. Of course, it's still possible to do the more, if you get off the beaten path, it's still possible to do it, but it's going to be, just as good as the other people are doing it. And also, we want to make sure that it's trivial to compile your application natively. When we talk about Quarkus, we very often mention supersonic subatomic, which is the marketing way of saying that it's really small, it's really fast, and it's really small as a footprint. So to give you an example, here we have some benchmarks we ran a few years ago for a typical REST application, where we look at the memory usage, and when you use Quarkus on the JVM, which is going to be probably the default way for you to use it, we have a memory footprint that is around half of what they used to be on traditional cloud-native stacks. And if you go the extra mile and go and compile natively on GraalVM, which we will talk about and demo later on, then it becomes really tiny. Now, if we look at a more realistic application where you don't do just REST, but you also connect to a database and talk to the database, the difference still holds. It's a little bit less of a difference between the Quarkus on the JVM and the traditional cloud-native stack, but as soon as you compile natively, you can see that the benefit still holds. In terms of startup time, it's even more striking. We made sure that Quarkus was very optimized and very fast and very, very memory efficient on the JVM. So you can see that the startup time is really much faster than what you're used to on traditional cloud-native stacks. Most of the time, the application starts in the blink of an eye. But if you go the extra mile and compile natively with GraalVM, then it's really instantaneous. So this is something that is very important for the cloud. A third area we focused on was we wanted to make sure that you could use imperative and reactive style of programming. So whenever you use Quarkus, you always have the choice between doing it in the blocking way, in the imperative way, and also do it in the reactive way. So to that end, we even have library to make reactive programming much easier, which is called Mutiny, which you see on the right with Multi. And we want to make sure that you can write parts of your application, even parts of your application in imperative style and other parts in reactive style. So wherever you have, you use the best tool for the job. So if one endpoint needs to be blocking, then you can do it this way. And if you have one endpoint that would benefit from being non-blocking and get the best performance, then you can do it this way as well. You can mix and match. And finally, we also want to make sure that Quarkus is relatively new. It's 2-3 years old, but it's not just that young. It's not just unproven and very young technology. It's also leveraging a lot of the frameworks that we've been using for the past 20 years, such as Hibernate and MicroProfile. Well, it's not 20 years old, but it's old enough. Vertex is very proven, Netty, etc. So we're using a lot of technology that is very robust and industry proven. And that's enough talking, right?
Yeah, let's see some code.
All right.
So now I'm going to do a bit of a demo. And this demo isn't going to really be about teaching you how to use Quarkus. It's more about showing you just how Quarkus enhances your workflow and the sort of experience you get as a developer when using Quarkus, and how we just try and make life as easy as possible for you. So
how do I start?
The best way to start is you just go to code.quarkus.io and you generate an app from here. So I'm going to create an app called JNation-to-do. Oops, to-do. I'm going to add some features to it. Now I'm going to need a web endpoint, so I'm going to add REST Easy Reactive Jackson. That's our HTTP library. I need a database, so I'm going to add Postgres. I'm going to need to talk to that database. So to do that, I'm going to use Hibernate. But Quarkus adds some extensions on top of Hibernate called Panache that basically make life easier for you as a developer and remove some boilerplate. So that's what I'm going to use for the database access. And we'll cut. So here's Hibernate RM with Panache. I'm also going to add Flyway to manage the schema. This is a very low resolution screen. And I'm going to add OpenAPI as well, just to because that's always good to have. So now I'll generate my application and download the zip. Now I'll open that up in IntelliJ.
You can see we rehearsed this 3 times.
I meant to delete my rehearsal projects beforehand, but I forgot. So
what do we have here?
So this is what we get when we download a project from code.quarkus.io. It's a standard Maven project. We have a standard POM file, which should be fairly familiar to most of you. We have dependency management, which is done via the Quarkus POM. So that just aligns all your dependencies so that you get the right ones that have been tested with Quarkus. And then we have our features that we selected from our code.quarkus.io. We also have the Quarkus Maven plugin, which is kind of what does all the magic and builds a Quarkus application at the end. There's also a separate profile down here for building a native application, but we'll talk about that a bit later.
Do we have any configuration?
No. We have an empty configuration file, but to get started, we don't need anything for config, even though we're using a database. We have a greeting resource, which is just a basic hello world endpoint. I'm going to change this into a to-do resource. We're going to write a to-do app. And then we'll get started.
You're going to break all the tests doing this, no?
That'll be all right. And now let's get started. So to get started, you just run mvn quarkus dev. And this will launch Quarkus in development mode. Now, you may have noticed that I added a database, but there's no configuration for that database. So what Quarkus will do is, as it's starting, it's detected that the database is missing, so it starts PostgreSQL for us in a Docker container. Now, we call this dev services, and it means that when you're running tests or working in dev mode, if you don't configure a service like a database or Kafka, Quarkus just detects that and starts it for you. So you don't need to sort of mess around setting up different test and development environments. Quarkus just handles all that for you behind the scenes.
That's nice.
So now we have a running application. Let's have a look at what this endpoint does. Now,
How do you go there? How do you open the endpoint?
Well, we need to go to a browser, but instead of just tabbing to my browser, this console down the bottom is actually interactive, and it provides a few shortcuts. And one of them is if you just press W, it will open the application in your browser, and then I can navigate to where I need to go. There's quite a few more shortcuts. Some of them we'll see today, but they're just little things that try and save you a bit of time and just make your life a little bit easier.
That's not the right hello world. We want to say hello to JNation. Can we do that?
Of course I can do that. So all we need to do, hello to JNation.
But now I need to recompile everything, repackage.
If I just refresh the browser, the changes are there immediately. Now this is what we call live reload, where Quarkus just takes care of everything behind the scenes, including compiling, restarting the application. And this will work for any change, not just simple ones like this. We can add a new endpoint. So I might change who we can say hello to. So path, name, rest path. So now we can say hello to someone in specific. All right, we've got that change. And we've said hello.
That was fast.
Now, for those of you who are familiar with JAX-RS, you might notice that this is a bit different to your standard JAX-RS annotation. This is just an extension that Quarkus has added that stops us having to repeat name again. So normally if you use JAX-RS, you have to add a name there, so then name is being repeated 3 times. And this is just a little bit of boilerplate that Quarkus lets you remove. If you're not familiar with JAX-RS, it really doesn't matter that much. It's basically just a way of mapping HTTP requests to endpoints. They're fairly self-explanatory annotations that map the method and the path to a request handler.
OK, I'm not convinced. You sold me a to-do app.
Well, all right, let's get started on the to-do part of the app. So the first thing we need is a way to, store our to-dos in a database. So I'm going to create a to-do entity.
Oh, that's going to be hard.
So this is just a standard JPA entity. We add the @entity annotation. And because we want to use Panache, the way we do that is we extend from Panache entity. So what this does is it adds a lot of utility methods and extra things that reduce boilerplate to our entity. So if you have a look at Panache entity, it has an ID, so I don't have to bother defining my own ID, because that's generally just boilerplate that gets copied over to every entity. And in this Panache entity base, there's a whole heap of utility and helper methods that mean that you don't need to use the entity manager directly and save quite a lot of boilerplate. So now let's add some fields to my entity. We need a title for the to-do. We'll add a URL as well.
So here we're using public fields and generating getters and setters behind the scenes, so you don't need to write all this. So you can focus on your model and not on generating code.
Yeah, that's pretty much all I need. Panache will take care of generating everything that Hibernate needs, as Steph just said. So now let's make sure this is working. I could go back to my browser and refresh, but this isn't really a change that's visible in the browser. So one of the other neat shortcuts that you've got is that if you just push S in the console down the bottom, it will restart. And oh no, I've got an error. Syntax error near order. So order is an SQL keyword, so I'd better fix that by renaming the column. So even though we're using Panache, we can still just use all our standard JPA stuff. Rename that to ordering. Go down here and press S again. And that's all live. So now we've got our database support up and running.
How do we list the number, all the to-dos from the endpoint?
Let's take our existing resource and modify it to be a to-do resource. So we'll change the endpoint to be /API. We go list, to-do, list. And before we're returning plain text, we want to return JSON now. So if we just delete this, REST Easy Reactive is smart enough to automatically realize that, oh, they're returning an object, they're going to want JSON. So it just avoids a bit of boilerplate. And now we will just return to-do.listAll.
Oh, this is where we see all the useful methods.
Oh, yeah, so I'll go back. So if you have a look, if I go to-do dot, there's a whole heap of utility methods. They correspond to database operations, and for the most part, they're relatively self-explanatory. But they just mean that you can write these methods with a lot less boilerplate. So we'll go list all, and then we'll sort ascending by order. And that's all we need. So now if we go back to our browser and hit refresh.
/API?
Yeah, /API.
It's empty. Oh, that's boring.
Yeah. So now I could go and add some test data to the database, but this is 2022. People tell us we should be using tests and test-based development. So
I heard about this thing called continuous testing, where I would write the test and then figure out how to implement them.
yeah, so rather than showing what we're going to do in the browser, we're going to use a new feature of Quarkus called continuous testing that will let us just write our tests and have Quarkus execute them immediately and basically make the testing experience much faster. So if I press R down here in the console, it will enable continuous testing, and we can see that the tests start to run down the bottom. Now, it's actually starting a second Postgres instance, just so that our test data and our development data don't interfere with each other. So your tests run in a clean, isolated environment, and you can't have things that you've done in dev mode giving you false, false errors or causing other problems. So if we have a look here at our summary, we've got a test failure, because obviously we're not saying hello anymore. We're not even returning the same endpoint anymore. So let's update our tests to be more accurate with what we're doing. So the first thing we're going to need is some test data. So what we'll do is we'll add an app before each method that adds this data.
That's JUnit.
Yeah, this is just standard JUnit. But we're going to need a transaction because we're adding data to the database. And with Quarkus, the easiest way to do that is with the Jakarta transactional annotation. So even though this is a test and not your application, you can still use basically anything that you'd expect to be able to use in your application, you can use in your tests as well, because tests are first-class components. So we'll go to-do.delete all, just in case there was any leftover CRUD from the test. We'll go to-do t equals new to-do, t.title equals prepare talk for JNation.
No, we don't prepare. We just give talks.
t.order equals 1, t.persistent flush. Now, I'll also need the ID for this for the database, so I'll go long to do ID. We'll save this. Oops. Save this so that we can get access to it later in our tests. t.id. So now we've got some test data. Let's write our test. So we want to get /API, and then we want to validate that the status code is 200. Now, with our old test, we were just testing against a string. But with Rest Assured, which is the testing library that Quarkus uses by default, we can actually also assert against JSON body components using JSON path. So I can actually specify a path here, which is object 0 in the list, dot title. Oops.
In the string.
In the string. And then we need to say that that is this string here, which I'll just make into a constant. And now if I save this class, we'll see down the bottom.
Oh, so you just save it?
Yeah, that now our test is passing. So there I actually hit Control-S to save it. Normally, if I just switch IntelliJ windows or go and do something else, the test will just run automatically, basically as I'm coding. And you can see the results immediately. So because we're doing test-based development, let's write some more tests and then make them work. So the first thing we're going to test, I guess, is adding something to the database, because that's
we need to be
fairly
able to
important.
add, to update, and to delete.
Okay, so to add something, we need to post. So we'll add something to the body of title is added, order is 2, content type needs to be JSON.
So we do this, and we're going to have a bunch of tests that fail.
And title will be
and then I have
added,
continuous development working here as well.
And then we'll just also test that once we've added it, it ends up in the list. And as well as our initial item, we also have
our 2 results.
New item. So now if I save now, we'll see that that test runs, and surprise, surprise, it fails. So let's test editing as well. So we'll do that via a patch method. Test edit. It's very simple. We'll just change our title to edited. And we need to actually post this to a different API. So we'll put the to-do ID into our URL and change the method to patch. And then
verify the title.
Verify this is edited. And then verify that there's one item in the list and its title is edited. So there's that test, and now we just need to delete the item. So let's test our delete method. Similar sort of thing. We don't have a body or a content type. We just post delete to that URL. Status code will be 204 because there's no content back from a delete. And then we assert here that the size of the resulting list is 0. So now we've got our tests. So if we save this, we should see that 3 tests failing out of the 4 tests run. We can just add them.
Now we just have to implement them.
Easy.
Famous last words.
So post, it will return a to-do.
Takes a to-do as well.
To-do. And all we do is call to-do, oops.
We just persist it.
Persist and flush. And then we'll return it. The only thing we're missing, though, is a transaction. So we'll add that. Now if I save it, we should see it working. Oops, it still failed. I think I've got a bug in my test. Instead of added, I had lowercase added. Whoops, I'll just fix that. Save the test. And now we're down to 2 tests passing.
Oh, this is cool. Instant results. That's instant gratification. It should be gamification.
Oops.
That was interesting.
That's not what the button I intended to hit. Now we'll add an edit method. So this needs an ID, so we'll go long ID.
Which you get from the path.
And yeah, we need a REST path annotation. We'll need to add a path here. Now we need to find our item from the database. Equals to-do.find by ID.
Another useful method.
And then we'll update our existing item with our new title.
Normally we would care about not found, etc., but not here.
Yeah, this is, we're not checking that it exists or anything like that here. What's wrong? Oh, I need to change the method. Yeah. And then existing.persist and flush, and we've done with edit, except for our updating our patch method. So now if I save that, we're down to 1 test failure. Got delete, which is even simpler.
We're getting there.
We just remove the body, find by ID dot delete, and just remove everything else. And now we should have everything pretty much working. And I save that, and all our tests are green.
Wow.
So now I've got a UI that I prepared earlier because I can't do UI programming at all. So in theory, because all my tests are passing, if I put this into the application, it should just work. So let's have a look and see. I've got my UI in this project, and I'll copy. Download, so what did I call it? JNation 223.
Number 3.
Source, main, resources, meta-inf resources. All right, so now if I go back to my browser, go to localhost/todo.html. We've got the UI. Let's see if it works.
Wow.
It works first go. So yeah, now we've got our to-do application developed using continuous testing and test-driven development. And cool. So we've been showing this in...
That's dev mode. How do I actually deploy my application on production?
Well, the first thing that we need to do is actually add some configuration. So far, we have pretty much managed to do all this without adding a single line of configuration. But to actually deploy in production, we are going to need some config. So we really need to do 2 things. We need to, A, configure the database so we know what to connect to. And B, we also need some way of managing the schema. Because at the moment, Hibernate is creating and dropping the schema each time. And that's not really what you want in a production application. At least I certainly don't. So to do that, we're going to use what we call dev UI just to make this configuration process easier. So if you press D down in the console here, it will open up our dev UI. Now, there's quite a lot of information here that you can use and features that you have. There's a configuration editor that I'll show in a second, and there's lots of information about what beans and other items you've got in your app. There's a link to Swagger UI, so you can actually have a look at all your endpoints and test them out. So you could just try out your post API and just tools to make your developers' life easier. There's
Every extension contributes to this page, so whenever you have more extensions, they can help you test themselves.
The other cool thing that's here that corresponds to what we've just seen is that you can also view those test results in the browser. So if looking at them in the console isn't really for you, you can just see them here, and they get updated immediately as things change. So if I update my test to be broken, if I go back here, boom, I can see the results straight away and see the full details and logs about what went wrong. So that's just one of the other way of using continuous testing. So now we need to turn our app into a production application. Now there is this big config editor here, and this lets you edit every config property in Quarkus.
That's a lot of them.
There's a lot of them. So because we mainly care about databases, there's actually more focused configuration editors. I'm going to look at the Hibernate ORM one, and it's just this little button down here, and it takes me to just the database config. And you can see here that there's these settings that have been automatically set by dev services, and they're basically the settings that we need for our database, things like URL, password, and the database type. So what we're going to do is, rather than manually entering these, there's just a little feature up here saying dev services copy to prod profile. We'll do that, and Quarkus has set those properties for us. Now I'm going to configure this to be
the person's
a locally
prod at the
running
beginning
database.
Means that this is only going to be applied when you're running on production.
So I'll create a new DB called JNtest. And I already have a user called Quarkus with a password called Quarkus. In production, you wouldn't normally do this. You'd inject these via environment variables. So normally these wouldn't even be in your config file. But this is just a demo, so this is just what we're going to show today. The other thing we need is some way of managing the schema. Now, Hibernate is great for development and testing, where it can just create the whole thing from scratch. But for production, you need like a proper way of managing schemas and versioning it. And that's what Flyway provides. So here is our Flyway extension, and it has some tools in the dev UI. So initially, this is all I've got, which is create initial migration file. I hit yes, and it basically takes the SQL that Hibernate has generated and uses that to seed your Flyway configuration, so you can get started with a more like professional and scalable way of managing the schema. So now I've got all my Flyway SQL here, and when I run my application, this will be triggered and will update the database schema. And it also adds a little bit of Flyway config that sort of makes sense for most apps. So now we're done.
How do you start it?
Well, we're going to build the application. We're going to skip tests because I've broken one of them deliberately. This will just take a few seconds to build. And now we have our Java application. Now the end result ends up in target Quarkus app Quarkus-run.jar. And boom, started in 1.3 seconds. So that's a full JVM app with transaction support, with Hibernate, with a database, and it just starts almost instantly. And it includes like Flyway creating the schema in this new database. Now, we can actually get it to start even faster than that if we compile to native, but which it could do by running nvn install -p native. But that will take a few minutes that we don't really have. You don't want to sit here watching my computer's fans go. So I've actually prepared one of these in advance. So if I just run my JNation to-do executable, boom, it starts in 0.2 seconds, most of which was Flyway sort of verifying the database schema. So yeah, and that's pretty much it for this to-do demo. Hopefully it's sort of shown you the sort of workflow that you can get with Quarkus and how Quarkus just goes out of its way to make your life easier by removing as many impediments to productivity as it can, by removing boilerplate and just giving you tools that give you instant feedback.
Thank you, that was impressive. So why are we talking about trying to reduce the memory usage and startup time? This is because nowadays, when you deploy your applications, you deploy them on the cloud. And when you deploy them on the cloud, these things matter because they end up being costs. So traditional applications used to be monolith, and when we made the move to microservices, we replaced a monolith with about 20 microservices, or at least dozens of them. If you go all the way and replace your monolith to lambdas and functions, then that amounts to even more of them. So it becomes important that also when you deploy to the cloud, you're able to scale to 0, and then startup time becomes an issue. You want your functions to start as fast as possible and be as small as possible in terms of memory usage. When you look at traditional enterprise Java, that was something that was designed for 3-tier architecture, where everything was running on top of an application server. So if you had multiple applications, they would all be using the same application server and run on it. Now, this is not how we deploy applications nowadays. The way we deploy applications is that we have microservices, and very often those microservices are written in using different technologies. So you would have one of them written Node.js, another one in Java Enterprise, another one in Microprofile or Spring Boot, and you orchestrate everything on things like Kubernetes. Now, we need to talk about the hidden truth about Java and containers. When you talk about the memory usage of the JVM, it turns out that a lot of the memory that you're using is actually used by the metaspace. So you have two overheads when running on the JVM. You have the startup time overhead, which depends on the number of classes that you have loaded in your application, on the size of the bytecode, and the just-in-time information, and the just-in-time compiler. And you also have memory overhead, which also depends on the number of classes that your application has, and contains a lot of metadata. The more classes you load in your JVM, the more metaspace they use, which is the area reserved to describe those classes to the JVM. And once you add anything to that metaspace, you can't actually remove them. So you want to make sure that you have as few classes as possible in your JVM to be able to use the maximum of your Java heap. Compilation also adds a lot of usage to the metaspace. So if you try to compare applications depending on if you compare the hotspot and traditional Java applications running on the JVM to Node.js and Go, traditionally they use a lot more memory, and so you would have to have very much fewer instances of the JVM running on the cloud as you would have Node.js and Go. One of the goals of Quarkus is to make sure that you can actually get a lot more money, a lot more bang for your buck, and run more Quarkus applications because they're smaller and they start up faster. So then it becomes competitive with Node.js and Go runtimes. So how do we do that?
Well, it's not just marketing speaks. Quarkus's whole architecture has been designed around starting fast and using less memory. Now, when you think about how a normal Java framework starts, traditionally you have your build time, so Maven and Gradle builds the application, and then once you've built it, you try and start it. So the first thing you'll do is something like loading configuration files. They might be YAML or XML, which means loading the XML parsers as well. You also need to scan your class path to figure out what annotations are present, because Java tends to be fairly annotation heavy. So at startup, you need to look through, find all those annotations, and basically take stock of them. And once you've then got all this information about what your application actually is and what it's supposed to be doing, you need to sort of build an internal meta model that represents that state. So if you've got a web mapping and an annotation, you need to actually set up your routes that will handle that, and basically set up your internal meta model that corresponds to all the annotations and configuration that you've read. And then once you've got that, you actually need to start all the services that let you service requests. So things like opening sockets, starting thread pools, all the bits that actually process requests. Now, Quarkus does this quite a bit differently. So we have our build time, same as anyone, we get built via Maven, but then the Quarkus Maven plugin actually does a lot more. At build time, we try and do all these other steps as part of our build time process. So we'll read all our config at build time, except for specific values that are runtime configurable. So things like JDBC URLs you can configure at runtime, but things that are more application specific you can't. We'll also do all our annotation scanning at build time. So we basically take stock of exactly what's in the application, and we know exactly what is going to happen at startup. And then we generate our own internal meta model, and we write that out into the application as basically a sequence of bytecode steps that represent just the minimum amount of work you need to do to start that application. So then when we go to actually start the application, all we need to do is run those steps that we've already configured, and that lets, and that's basically the fastest way to start an application. And this actually gives us an additional benefit as well. So Steph was just saying that the more classes you load, the slower things are to start, and the more memory you use. Well, all this processing back at the first part here, that uses a lot of classes. And because we do all this at build time, none of these classes actually make it into the final application. So we don't have to load them at the start, which takes time, and we don't have them sitting around in memory for the life of the application. So this is sort of the key to Quarkus's architecture that actually allows it to be smaller and faster than traditional frameworks. So what we call this really is a closed world assumption. Previously, applications could kind of be configured more at runtime, and you couldn't really make these build time assumptions. But with containers, that's not really the case anymore. When you put something in a container, it basically becomes immutable. So building your application to be immutable and then putting it into an immutable container actually makes a lot of sense. Yeah, and we get a lot of benefits from that, as we just don't have to do as much work at runtime. So this is kind of what the Quarkus architecture looks like. We have all our Quarkus extensions, and they just sit on top of a small core. Now, Quarkus is basically a framework where you need to pick what you want. We don't package all our extensions into one thing and you just pick which ones you enable. If you want a feature, you need to explicitly select it. And that also helps keep the code size small, because you're not paying for anything that you're not actually going to use, and it doesn't actually end up in your application. Now, this architecture diagram doesn't really tell the full story, because really, it looks more like this. For every extension that you have in Quarkus, there's actually two parts. There's a deployment time part that will do things like the annotation processing and try and figure out what needs to happen at runtime. And then there's a runtime part that will do things like actually servicing requests and making the application run. And then there's kind of a core deployment framework that does all this processing. It uses some libraries we've written called Gizmo for generating bytecode, a library called Jandex for efficiently reading annotations. But all this code just stays at the deployment side. And at runtime, we just run our recorded startup time. We have a very minimal core runtime, and just the bits of the extensions that are actually needed to make your application run. Now, Steph's going to talk about this next bit, and this is about how we deal with native images and compiling Quarkus applications down to native executables.
So, to do native compilation, we rely on the Growl compiler, which is a rather huge project which has lots of bits to it. Allows you to run Ruby, JavaScript, and even generate some LLVM bytecode. But the bit that we're going to focus on is the bit called Substrate VM, which is the native image tool that, well, we didn't actually show it, but that's the thing that would melt your CPU. And for a good reason, because it compiles things on all the cores. It's very efficient. So the way this works is that you have this compiler that will take your Java application classes, would also take the JDK classes, and then it would have a bunch of substrate VM classes as well that describe exactly how to map certain cases of how to special case certain classes into native code. And it takes all this, and then it's going to run with a closed world assumption and look at your bytecode and try to start from your application and try to see everything that is reachable. And so it's going to eliminate a lot of dead code. And one of the big reasons for that is not just your application, but it's also your dependencies, because when you have a Maven application, you have hundreds of dependencies, even if you're using Quarkus. And you don't have just those dependencies, but you also have the JVM. The JVM needs to be packaged in your application. And you don't want to compile the entire JVM to a native executable. There are lots of places, parts of the JVM that you are never going to use. So it's going to traverse your bytecode and remove all the bytecode that you're not actually using, and only compile the small part of the JVM and of your dependencies that you need, so that your compiled executable is going to be small enough to actually be useful. Now, there are a number of things that are a bit different when you're running on native image. For instance, you have a number of things that are not supported, such as dynamic class loading. So as I said, everything that is not noticed at build time is going to be dead code eliminated. So you can't really load dynamically classes at runtime. But this is something that we avoid anyway with Quarkus. Well, you don't have invoke dynamic and method handles, but that's not very important. Security manager is not very important either. And you have things that are OK, but you have some caveats, such as the usage of reflection, because you can use reflection, but you need to mark which classes need to be enabled for reflection. And the reason is that we don't have the class bytecode at runtime, so we need to generate some information for reflection libraries to be able to use them. And so what Quarkus does at build time is that, depending on the framework, if a certain framework knows that at runtime we're going to need reflection for a number of classes, it's going to record that and tell Quarkus, OK, I'm going to need reflection for those classes. Please produce reflection information for native compilation. The same is true of dynamic proxies. So at build time, we pick up the list of proxies that we know we are going to use at runtime, because we know your application, we know how Hibernate works, how REST reactive works. We can optimize this. And we also optimize static initializers, because we know some frameworks need to be can be initialized at build time, and others need to have parts running initialized at runtime. So we can separate those things and make sure that we push as much as possible at build time, but some things like opening sockets, etc., all this, starting threads, all this needs to happen at runtime.
Yeah.
Now the question is, when do you use which VM with Quarkus? What we advise is that, obviously, the easiest, if you want to use dev mode, etc., and you have all the tooling you have the debugger, you have the profilers, then you're going to do all your development on the JVM mode. So you're going to do all your development on the JVM, and this is you already get a fast startup time, and you have, but you have. That's also where you get the best CPU performance, because the JIT can actually optimize your application better than native compilation. You also have the best garbage collector, but the downside is that you have the highest heap usage. On the other hand, if you run natively, then you get faster startup time, but you have a slightly worse GC and a slightly worse performance. So the question now becomes how exactly you deploy this. And very often people would tend to have long-running processes deployed of their application running on the JVM, because as soon as you send some traffic to them, then they get very optimized and they can run fast enough. And whenever you have some peak usage and you need to start scaling out, you can run them on native image, because they will run faster, and it doesn't really matter if they're a bit slower than the JVM. You just start up much more of them, and then you scale them to 0. So that's one of the options. If you're doing serverless, probably you need the native one, because then that's the one that starts fastest and scales to 0. So the Quarkus core, all the core extensions.
2 minutes.
All right. All the core extensions, we make sure that they're supported on GraalVM. So out of the box, everything you can use on Quarkus will work on GraalVM. We make sure of that. And a question that is very often asked is, can I add my own dependencies, or do you need to use the Quarkus extension that we wrote for that? You can add your own dependency. It will always work on the JVM. And it may or may not work on GraalVM, but you can try. And if it doesn't work on GraalVM, then you can write your own extension and start adding support for native compilation to it. And then take it from there and add more things like build time, startup, and memory improvement, and developer joy to it.
That's that.
There's that.
Thanks, everyone, for coming. Do you have any questions? No questions? I don't know if I'd actually be able to see if anyone had their hand up anyway.
Yeah. One question over there.
Só segundinho, eu vou levar o microfone.
Somebody is coming with the microphone.
Hello.
Oh, sorry.
I was just going to kick things off by asking, so what happens if I've got like a lot of unit tests, like 5 or 10 minutes worth? How is that going to help with continuous testing?
So you can include or exclude tests. So if you've got really slow ones, you could, say, add a tag to them and exclude that tag. If you've just got a really big test suite, continuous testing only runs the tests that are directly affected by your code change, which is really hard to show in a demo like this when you've only got 1 or 2 classes. But if you had 100 tests and like 1,000 different classes in your application, it won't run all the tests in every change. It actually tracks which tests affect which code using a technique similar to what code coverage tools do. And it uses that to figure out which tests need to be run every time. So even with large applications, it still gives you really fast feedback.
And that's really a killer feature. That's very important. There was a hand raised over there.
Hi. I didn't quite catch when it's better to use the JVM versus the native VM.
So you're better off using JVM if you really want to run a Quarkus app using in sort of not much memory, or if it's going to be started up and stopped very frequently. So if it's like something like a function and it might be, it might only live for 10 seconds, then you're better off using native because it's got no warm-up time and it can run in a lot smaller memory. If you've got a large heap and it's going to be long-running, you're better off using the JVM. So if you've got something that has access to a gigabyte of heap and is going to be around all day, the JVM is going to give you much better performance. Is there any more? I can't really see.
No? All right. Well, then thank you for coming.